Welcome to this 11th railway talk of the WEIV. We are the umbrella of the Engineering Railway Association in Europe. And this evening we will have our 11th talk. The topics are VR, virtual reality, AR, augmented reality, and AI, artificial intelligence. We have two speakers. First of all, some words about me. I am Markus Corradini. I am a member of the GDI, the Swiss Engineering Railway Association, and on behalf of WEIV, I introduced to this meeting. We have two speakers. The first one is Luca Gioiello. He is an engineer, and he's now doing a PhD, and he works at Mercitalia Rail. And the second speaker is Markus Bolli. He is the owner of Suprexa in Switzerland. And the development of the railway talk will see the presentation of the two speakers, and you can put the question in the chat or raise your hand, but raise your hand only at the end of the both presentation. So the first part will be the two presentation, and then there will be you will have the space to put your question and get the answers. So I give the floor to Luca Gioiello as first speakers, and then you, Luca, to Markus. Thank you very much.
Great. I will share my screen. Can you see it? Great. So thank you everyone for joining this 11th Railway Talk today about new technologies and in railway operations. And just quick information about me. I am Luca Gioiello. I am a safety engineer, and I focus my academic career on transportation and safety systems. I'm currently in my second year of a PhD in industrial PhD in technologies for resilient living environments at Università of Campania Luigi Vanvitelli, where I'm focusing my research on transportation and safety related topics in the railway field. On professional side, I started my career in 2020 in Mercitalia Rail in Group OFS, which is the leading freight railway company in Italy. And alongside, I started my career as a train driver in 2020. And then I have done some experience with locomotive shift planning and safety management systems. And currently, I'm working in the operational department, focusing on production activities in Lombardy region. So just a very quick overview about the railway system. Over the last 25 years, the European Commission has been proactively in proposing changes to Europe's rail transport market. And a lot of efforts has been put in three main areas, such as opening the rail transport market to competition, improving interoperability and safety, developing rail infrastructure. And that means that we need more technology in the railway system to ensure safety and reliability. So today we're going to talk about virtual reality, augmented reality, and artificial intelligence and their practical application in railway operations. But of course, I would even like to talk about the role of human factor and just culture. So virtual reality was a concept introduced in 1963 by Ivan Sutherland. He was a computer scientist. And for the very first time, he introduced the concept of the ultimate display, which is an hypothetical and navigable virtual world entirely designed and constructed within a computer. That means that all the real world is reproduced virtually in a virtual environment to do some actions. Later on in 1968, he developed the HMD, which is the head-mounted display. It's a special device that allows you to put and operate into a virtual and virtual environment like the one we see here. Later on, another device was developed, such as the data glove. Basically, this device is used to reply some actions you do in the real life, such as the movements of your hands in the virtual environment. So some studies have said that we can distinguish 4 main categories of transportation and logistics where we can apply virtual reality, such air, field, maritime, railway, and road. Within them, we can have 6 clusters of research, like the operator training in routine procedures, operator training in incident handling, simulation of carriers, design of traffic infrastructure and carriers, psychological studies on transportation and logistics operators associated parties, treatment of illness related to transportation and logistics. As we can see from this graph, we can see how virtual reality has been applied during the period from 2010 to 2023. So we have a lot of efforts in the road system. Then we have the maritime one, the air, and the railway system. If we wanted to analyze the following of the studies during this period, we see that the gray line has his highest value in 2019, which is the year where a lot of research has been done to the application of virtual reality in the railway field. And even we can highlight in which cluster it's mostly used virtual reality in railway sector, and it's the one in operator training in incident handling. So basically, the innovative features of virtual reality are immersion and interactivity. Immersion is the ability to remove the user from the real world through the use of screens and air-mounted displays like the one we have seen before, while interactivity is the ability to produce a continuous flow of images at the exact moment they are requested. Now we see some practical application of virtual reality. The first one is about the infrastructure and how people are trained to do inspection during the infrastructure. So basically, once you put your head-mounted device over your head, you have been put into an immersive and virtual world, and there is where the immersion and the orientation starts. So at launch, the operators will see a digital and virtual environment, and you can even see some features like indication, like the one we see in the picture, that shows you where you have to go to look out the defects. In this case, you have to move from point A to point B of 5 meters. So you can move inside your virtual reality tool thanks to the feature of teleportation. Teleportation is a feature that allows you, by the use of a controller, to move from a point to another of the virtual reality world. In this case, people can be trained to identify and select defected bolts, like the one we see in the picture. So basically, the user via the controller can point each bolt and active contextual menus. Once the bolt is identified, you can click on it and you can select one of the 3 options, which are no defect, check, and fix it. And each time you select one of these 3 options, the colors of the bolt will change. Then you have the final part, which is the confirmation and completion of operations. So when you finish your mission, you can confirm that everything has been done, and then you can complete what you have started. Another application of virtual reality is in wagons inspections, and this application is very useful for ground staff. Basically, you can see that we have 4 main areas. So in area 1, which is inspector visibility, The instructor observes the inspector's actions as if he were the inspector himself. In area 2, we see that we can select from a checkbox the part of the wagons that need to be replaced with the faulty ones. Then we have area 3, which is the minimap, which displays the current location of the instructors and inspectors' avatars relative to the car model. And finally, we have area 4, which is the instructor's visibility. So the instructor observes the 3D scene and uses the mouse to change the viewing angle of his avatar. As we can see in this picture, this is how it basically works a virtual reality tool. We have the main user, which is the inspector in this case, which is wearing the HMD and the controller to move from a part to another of the scene. On the back, we see that we have the other person who is looking how the things are going in the scene during the training. And the most interesting thing about virtual reality is that you can change your point of view. So basically, if you want to inspect the bogie, the lower part of the wagon, you will see that your point of view will change as it will be in the normal life, in the real life. So basically, we can say that virtual reality, it's useful to train personnel, to assist operators, to reduce errors, and to document and analyze data on both status, like in the case we have analyzed before. Now we move to augmented reality. So basically, augmented reality is a technological evolution of virtual reality. We don't want to rebuild a virtual world, like in the case of virtual reality, but we want to add information to the real world. So basically, we integrate informations, images, manuals to the real world, thanks to special devices we will see later. And we can even connect the operator directly to the control centers. Augmented reality is possible thanks to these special devices, which are basically special glasses. And we can have different types of these glasses, like the one we see in picture A. This one is an optical see-through device that allows you to see special holograms. And you can use this device without having any other devices, such as tablets or books, to be consulted during your work. I have put an example of how augmented reality in railway operation is used. In this case, we see some workers doing maintenance activities. And we see that thanks to augmented reality, they can see virtual model of the part they need, and they can even consult some information in the hologram we see in picture B. And even in this case, we see this worker in picture B that it's pointing some part of the hologram, and this is useful to consult the information you need. Another application of augmented reality in railway operations is the one about wagons inspections. So you can use this device to, let's say, check all the parts that are requested to be checked before the departure of the train. So in this case, the operator is checking the serial number of the wagon, and it's automatically saved, as you can see in the lowest part of the hologram. So you don't need to do this process manually. So again, if you need help, the operator can ask support to the control, and they can display through this device all the information they need to complete their railway operations. So again, we see that this device is very useful to education and training, operation, supporting activities, service, safety, and digitalization of processes. Now we have an introduction of artificial intelligence. So artificial intelligence refers to systems that display intelligent behavior by analyzing their environment and taking action with some degree of autonomy to achieve specific goals. We can classify artificial intelligence into three main categories. So unsupervised learning, which is systems capable of learning without the need for pre-classified data. Supervised learning. This is a learning technique in which the model is fed training examples composed of an input vector X and the expected outcome Y. In this case, the example is said to be labeled, meaning pre-classified. And finally, we have semi-supervised learning. In this case, learning takes place by using input data that is only partially pre-classified, and that's called semi-labeled. If we see the distribution of papers for the period 2010 to 2020, we see that in the last years we have a lot of interest for the application of artificial intelligence in railway systems in general. We can even divide the five main areas of application of artificial intelligence in railway systems. So the main area is maintenance and inspection, traffic planning and management, safety and security, autonomous driving and control, and passenger mobility. We can also analyze some subdomains that have been applied to each of the main area. Like the case of maintenance and inspection, we see that the 49% is about defect detection. Then we have fault detection and diagnosis, defect prediction, failure prediction, maintenance planning, and autonomous maintenance. So I would like to talk about computer vision, which is a subfield of artificial intelligence, because we're going to propose some examples about this technique. So basically, computer vision equips machines with the ability to process and analyze and interpret visual inputs such as images and videos. And computer vision algorithms can be trained on a wide range of tasks, such as image recognition, image classification, object detection, scene understanding, facial recognition, pose estimation, and visual inspections. Of course, that means that if we want to do something related to computer vision, we need a lot of images to train our algorithms and our model, because the more image we have, and the best our model will be performed. Now we see some research that I have done about computer vision and the application in railway operation. So basically, what I discovered is that computer vision in safety in a railway operation is mainly used for infrastructure defect detection. Then we have application for intrusions and obstacles, catenary and pantographs, railway vehicles, personnel and safety. Now we see some examples. So artificial intelligence, such as computer vision, is used for infrastructure defects detection. We can see that thanks to a camera and a trained algorithm, we can check the problems with the fasteners or missing parts of the truck, or we can even find out if the truck has some defects. Then we have the application of computer vision applied to intrusions and obstacles. In this case, we see that all these square boxes highlight the presence of the unattended person along the track side. And the system is able to understand if the object or the person is related, is highlighted. And it also gives us some information about the trust of the operation. So it says that in this case, at 96% of possibility, you have a person on the track side. Another application again is the one applied to catenary and pantographs. So we can check all the missing part and the faulty part of the overhead system. So again, we have the boxes with different colors. Each of them highlight a specific part of the check that the artificial intelligence does. And it says us if there are some problems that need to be highlighted. Again, we can use this technology for railway vehicles inspections. So we see here in this picture that there are some parts that are identified, which are identified from the artificial intelligence. And it's very useful to do something that gives us a margin of safety. So it can speed up our operation and ensure safety. And the last application is the one about personnel and safety. So some application has been done to dispatchers to just figure out if the workers are falling asleep. So if workers are falling asleep during the shift, the artificial intelligence could say that there are some dangerous situations. So as we can see, a lot of efforts has been put in railway engineering in the field of safety thanks to artificial intelligence, but we have to do more in practical to let this technology reliable and applied in our context. But what comes next? I think that technology must support workers. So the keywords are balance between the human factor and technology. We can see that the Railway Safety Directive 2016 number 798 says that railway system in general should encourage to contribute to development of safety while confidentially is ensured. Staff is encouraged to contribute to the development of safety while ensuring confidentially. And it's all about the occurrence of reporting. So workers are called to report the dangerous situation, and they have to be, this reporting should be confidentially ensured. So to achieve this goal, it's necessary to abandon the culture of blame, of course, encourage free and honest reporting, and equip ourselves to manage it. I would like to share with you the meaning of just culture. So just culture means a culture in which frontline operators or other persons are not punished for actions, omission, or decision taken by them that are commensurate with their experience and training, but in which gross negligence, willful violations, and destructive acts are not tolerated. So I would like to share with you some examples. So we can have voluntary violation, such as suicide and sabotage, like the German wings pilot Anders Lubitz decided to commit suicide while flying the plane. Then we have failure to follow procedures. So the operator does not follow procedures because they want to finish quickly and go home. Rules not properly executed. So continuous training and skills maintenance are necessary. Organization did not adequately select and prepare the operator. Procedure designed without considering actual application. All operators in the same situation make the same mistakes. And distraction during task execution, like the case of Santiago de Compostela accident. So I think that we should focus on what went wrong rather than who caused the problem, because a just culture is the opposite of a blame culture. But we have to keep in mind that a just culture is not the same as a no blame culture. So individuals may still be held accountable for their misconduct or negligence. And a just culture helps create an environment where individuals feel free to report errors and help the organization to learn from mistakes. So if we want to improve our safety and our reliability in railway system, I think that we should find out the balance between a just culture and technology. So I thank you all for your attention, and I give the speech to Markus Bolli.
Okay, I hope you can hear me. Yes, I get the sign.
Yes.
That is perfect. Thank you very much. So let me go. So first, thank you very much that I get this platform to share my experience in automatization and stuff like that. And first, I saw by our guests some names that are well known. Hello, Philip. Hello, Andreas Haas from Swiss Rail, and Matthias and Roland. It's really great to be together with you in this session. So let me begin. We talk about far IE, and we will find out is it from the devil or is it an angel? Things we can create a new reality, and that's why I like the controversy in sociocultural context. First, about me, because not everybody knows me, just a name. I'm an organization developer since the last 40 years. I'm a lecturer, a designer for airplane and special vehicles, and the co-founder of the Kobo Economic Philosophy. And who knows me, they know I'm a big Lego fan. But I think you are not interested in this. You will see what is the topics in railway business. So I was the first ETCS IOP on the world. That was the Neubaustrecke in Switzerland and the Lötschberg Tunnel. And I create the first generic approval process for ETCS environments. Still work today, and also I was in the approval process for the Gotthard Basis Tunnel, so maybe I have a little experience in integral stuffs by railway. And then I was for many years in the Smart Rail 4 program. Especially I created prototypes for ATO Goa 2 on ETCS, full supervision. The sources you can read by yourself, find out in internet, or you can ordering that. Thank you. So the preamble is, I have been the transformation in various industries the last 30 years. And what I found out is that technology is always developing faster than the socio-cultural context. And that makes me wondering. Also, companies like Google, Facebook, Temu, Amazon, and so on, they believe they are already in the industry level 4. But even these kinds of company are still standing in industry level 3 by using microelectronics. And that's why we haven't reached the industry level 4. And for that, I will explain you a little bit more. The first result is to go into the next level of industry 4. We do not have any technical restrictions. That means, on the other hand, heavy sociocultural barriers there. Why we cannot go further on, as we are still in the same position as 25 years ago. But we should be here in the matrix, something like that. That's my feeling. So I will say, what kind of future we will have? And the future could be like that. We live in the matrix with Terminators, movies, stuffs like that. Or I hope we go in a peaceful area of social justice based on science and empathy. That is my big hope. Also, the virtual reality and artificial intelligence help us to reach this target. A Chan Buddhist metaphor about that is, a hammer is a hammer is a hammer. You can use it to create sculptures, arts, or forge words to kill people. Anyway, the hammer is just a hammer. I talk about tools. So, in the introduction, I will show you how important it is to clarify the words, what it means that we can sharpen our mindset. The degree of understanding corresponds with your feeling. High understanding causes high feeling. Poor understanding or misunderstanding causes bad motions. We can measure that with, we tell them the understanding compass. And of course, we will have a good feeling for this evening together with us, and that you can feel comfortable. I introduce you the program. First, the introduction, why word clearing is important, complexity in the railway business, new time, new rule. And the final sport, we go on the target, and then we make a conclusion. For that, I calculate 25 minutes. I hope you can following me, and you will have at last a lot of questions. By the way, the English translation is done by Google, so not my responsibility. And people that know my system, they have the pictograms on the left side of the screen: heart, the world, the globe, the head, the spirit, and the hand. However, word clarification is really important, because it is absolutely wrong that the word have only one meaning. I will use the word process in 3 different contexts: in chemistry, engineering, and legal profession. And each person is in this environment have an absolutely other understanding of the word process. And that's why it's absolutely clear we need a commitment, we need references like Duden or something like that, and we have to show up the context we talk about. That's also important when we talk now about artificial intelligence and VAR. The strongest agreement we can have is the law, of course, and standardization. And now let me show you what we understand by industrialization and what it means also for the railway business. Industrialization is not only a modern time matter, it is also in the classic we see by Troya, 24,000 BC. So this works, the phalanx works only when you have a standardized mass production of spears and shields. Without that, it does not work. And the Egypts, they have a so high mobility and standardized modular systems that they can nicket the boats and go through the desert and go in the next sea and use the same boats. Fantastic. And the Romans have a long-term success because they're really masters of mass production of consumer and production goods. And my favorite is Sir Francis Drake, because with his idea of standardization, his boat, the Revenge, was so high powerful that he can fight the Spanish Armada. You can read more in this. What fact is, by each jump in the next industrial level, the war is beside that. That's a mess. That is absolutely, for me, horrible. It starts by Luther, the Peasants' Revolution, the 30-Year War, then the American-French Revolution, Napoleon, Russian Revolution, World War I, World War II, and now we have the imperials fighting between the economic system America against China. And of course, we know that in the Ukraine, it's really a sad time. However, we look to the Industrial Revolution and we say there was the mechanization of product and social crisis is following. Then we make the automatization in product lines. Because of that, it's changed the primacy from capitalism to the primacy of production. In the next level, because we have an overcapacity in the production resources, now it's changed. Now becomes the primacy of the market. They say the rule of economical systems. And now we should living in a primacy of data, networking of people, machines, logistics and products at once, that we can really enjoy the next generation. And in the Swiss law already is fixed that we should go to net zero by CO2 and so on and so on. And we start for a regenerative economic system and social justice. But you see, the last one is in future. I do not know where it goes. Maybe in 20 years we can see where we will be. There is more information about that you can read also by yourself. And fact is that the industrial revolution and transformation has always profound changes in the society. And I think by myself, we are also on a board for a really big change. So the last year in my speech in Berlin, I talk about the hypercomplexity problems. And so the hypercomplex problems can only be translated into a simple solution with the help of complex ICT systems and AI-supported simulation. I believe in that. and as well as through the unique cognitive abilities of humans. So Luca already talked about we need the balance between technology and human being. That's why I say artificial and intelligence are a contradiction in terms. Why? Duden, this is the reference of German words, intelligence is the human capacity to think abstractly and rationally and to derive proposal actions from this. So that means if intelligence is according to the Duden dictionary reserved for humans, it cannot be artificial or synthetic. Therefore, artificial intelligence is a black-gray horse. That's fact. But however, we use the word as we use it, and so it's better to ride a black-gray horse than to walk. Now give me some chance to explain what is the difference between easy, simple, complicated, complex, and hypercomplex. Often, especially by translation in English, complicated and complex was mixed. In many books, it's a mess. This is now based on the science of the University of St. Gallen, and so we talk about factors, dynamics, and interactions. So complicated problems have many factors, but few dynamics and few interactions. Complex problems have few factors, high dynamic, and much interactions. And now the hypercomplex problems have many factors and extremely high dynamic and extremely high interaction. And in modern questions, almost we have hypercomplex problems and hypercomplex systems. For an example, the coffee drinking. In my point of view, nothing is much more complex than to bring a coffee cup on the table with a coffee. To make the coffee is very simple. It's a simple problem, especially with the modern caps machines. But if you have to integrate the technology of the coffee machine, the system becomes to be complicated. When I integrate in the perspective the resources for coffee preparation, cultivation, water, energy, and so on, then it is a complex system. And now, in the Swiss code, Article 964b, we are ordered to have a CO2 footprint by 00, a circular economic and social compatibility on the world. And that means when we have an end-to-end perspective over a system, it's always hypercomplex. And you cannot do handling hypercomplexity with semi-manual methods. Do not work. That means often the people think it is founded by myself. It's not, unfortunately not. There have many philosophy and scientists. They write books about that. And so this is our profit to use these books and talk together with these people. The result too is we have the system theoretical foundations for Industry 4.0 since the 70s. This is more than 30 years. See cybernetics by Ashby, Förster, Malik, Ulrich, Probst, and so on and so on. And the philosophical and psychological ideas we have since the 1950s. We see also by the speech from Luca how old the mask is for virtual reality. It's from the 60s. So where we are, why we don't move. Complexity by the railway business. So I'm a dinosaur of ETCS, and that's why I talk about ETCS. You see here the environment, many factors, but few dynamic and few interactions. The Eurobalise, the onboard unit, European Vital computer, the DMI in the cab, odometry stuffs, and the trackside radio block center with the performance data, and of course, very important, transmission by GSM. And when we go now with the regulation, we become a high dynamic and much interaction more. So you see on the left hand, the automatic train protection, it's defined by the subset 26. This is a system encapsulated by themselves, and then we have the interface to ATO with the subset 130, and then we have the world of the ATO environments and TSIs. So at last, it is still not only difficult, it comes to be complex. Now the next step. So we see the processes by themselves. We have the TMS, we have the local driver by Goa2, we have the DMI, the joystick, and at last in the TMS we made the segment file and the journey file. We generate that, send that to the train. The onboard unit can read it and optimize the curve under the restriction of the movement authority from ETCS. And so we don't need the DMI, we don't need the joystick, and the driver, they can be the supervisor in the cup. So that means the distance time diagram is generated in the traffic management system. This is the superbrain of all what is going on in the perimeter of a railway business. And the transmitter by themselves, sorry, it is seal 1 maximum, because seal 4 systems is ETCS and the TMS by themselves. That's why we can say the business is definitely many factors, few dynamics, few interactions, and also complex because we have few factors, high dynamic and much interactions, especially when we look about the organization. And this is the organization. You see how many facts we have. We must integrate it in an ATO environment, and now it becomes too hyper complex. That means we have not only many factors, we have extremely high dynamic and extremely high interaction to create and design this system. That means, again, we cannot do that with semi-manual systems. Do not work. That means we have a new time that needs also new rule. This is based on the MIT scientist John O'Brudet. So in the past, we have a pencil. From the pencil, we go to the typewriter. The typewriter becomes electrical power, and then we have the personal computer, but still we work same. We do the same things, we do it just a little bit more efficiently. And then comes the change, the turn of era in the year 2000. Now we should be in the industry 4. We should have the primacy of the data. What it means, any kind of report I need, also the report I need for visual reality, and all this fact of data means I need a meta cloud of relevant data just in time, that it works. And then we go enter in the industry 5.0 in the primacy of nature in the world of circular economic. This is a new renewal. We do not only the same things, we do new things, and this we do in a different way than we have done before. On the left hand, you see investment. On the right hand, you see innovation. That's why means innovation is always disruptive. In the technology, we have to jump a little bit over 2000, but you see the society still stops in the industry level 3.0, and we cannot go further on. And also in technology, we have in the lab, we have a lot of many great solutions, but it's not established in our society yet. So a student of mine, he asked me and said, but you see, before 2000, we fly to the moon. This was complex. So no, sorry, it's not complex. It's extremely complicated, but it's definitely not complex. Why? Complicated problems have many factors, little dynamic and little interaction. You see, the booster is a booster is a booster. That's the same booster by the Saturn V than we have by the V2. And the flight looks a ballistic event. You see, fire and forget, more and less. Not only. It's like a flight of an arrow. And if you release it, he fly in the target. And for the navigation, they have simple optical devices similar to a sextant that they can reach the moon at last. So a lot of simple problems, because there are many of them, it becomes to be complicated, but it was not in the definition of its complex. The complexity and hypercomplexity. What is the big change? This is the amount of information we need in a process and the networking. This built us the icosaeder as a metaphor, and now we go in a higher acceleration of information. That means when we have before a separate space and time area, now we have a space-time structuring of similarity. That means we go also in the Heisenberg's principle. You can say what the system is, the existence, or what the effect is of the system, but you cannot say the same in the same time both. That is one of the traps we have, and we have to reach that we can do it. So not, again, by the theorem of Ashby, the variety of the system dictates the variety of the method which the system can be controlled. That means by simple problems and complicated problems, we can make a multiple linear sequential method to find a solution that do not work anymore. By complex to hypercomplex problems, we need a multi-incremental, circular, evolutionary, iterative method. Sorry, this wording is not from me. It comes from the University of St. Gall. And in my experience, they are right. That means when we look to the operation process in railway business, it is define the process of achievement, support, leadership, education, supervising, optimizing, blah, blah, and so on. It is created and defined by standards, by law, by international contracts, and driving regulations, and the performance agreement. In Switzerland, it's easy. The cantons, they make a performance agreement with the nation. The nation, the Minister of Transport, ordered the authority to deliver this performance. This is classic. This is the level industry 3.0, and it works very well the last 50 or 100 years maybe. And now comes the change of the world. Demography, topology, topography, geography, and geology. All these stuffs are changed very quick, and that means because we have really causality between these steps, the operating processes have to be variable as the geology, geography, topography, topology, and demography is changeable also. That means also here we have many factors, extremely high dynamics and extremely high interaction. That means the railway business is, by the end-to-end perspective, industry level 4, and we talk about complexity systems and hypercomplexity processes. We can reach simple solutions if we deaccelerate the hypercomplexity, we fix it for the moment, we bring out the factor of time and changeability. And then we create it in the processes, we relate it to the processes. The entities we fulfill with the attributes they need, and if we do have it, we can also see what is the effect of an organization in operations, technology, business, or management. If we do have it, we can make functional clusters. Functional clusters are based on the Marco-McMahon, and with this system, we create now a mathematic Petri net. And this is a one-by-one basic to make the software very easy, very quick, and then we can apply the solution that we have it on a tablet or whatever else. And all this stuff, you cannot handling with semi-manual methods like Word, Excel, and stuff like that. So we have an example for the simulation. I work together with the company Icondu. They developed a simulation, a virtual reality room and space to develop the transformation to reach the 70 Sustainable Development Goals from the UNO. And with the disposition of that, you really can have a preposition that you can really simulate very close to the reality, but in a virtual space. And that's why it's so important we can use the virtual reality based on a metadata cloud. Also last year, they introduced us a prototype. So they make the data, the basic data of the automatic coupling of the flirt from the company Stadl. So they control the room also with satellites. So when the task was now open the screw, the system knows the screw is not allowed to open until the fuse is still switched on. So the system remarks, guide the operator, he goes in the train to the cabinet, open the cabinet, find the right switch and switch off the fuse. And then he can work further on. It's perfect, but it's just level 3 and not level 4, because the database for this action is done by hand. It's just a standalone lab solution. The stringency of the data do not exist because the manual input of the printouts of the origin data of the production. So we have no change management according to ITIL. So how I can say this never work. So we need this performance, but we do not have it. Still, we do it by hand with people, and so we have we break the chain of information. That sounds like science fiction. I know that, but really, I'm long enough with that. You see, in the 80s, already the circular system of problem solution finding is created by the University of St. Gallen by Professor Ulrich, Probst and Gomez, and of course of Malik, and they describe it. Me, I was inspired of that when I start in the 2006, I create first the information system to handle the approval process for any ETCS environment worldwide. So we make, we call them CORAMIS, Corridor A Management Information System for digitalization, and IA-based approval process. That means that only with one tip on the keyboard, the system print out what is the gap of your German approval and what you need as an add-on, for an example, reversing, when you will pass the Gotthard tunnel. And that should be in a community data cloud. But in fact, they are not interested in that. The reality is that they do by hand. And really, this process, approval process of railway systems in Europe is a multi-billion business to create documents and reports by hand. However, and when we will go now in the next level of level 4 and 5, we come in a contradiction. We will reach the target of social fairness. We will have the CO2 netto calculation. So we need really new farms of computers. These farms are so high performed, they need exorbitant amount of energy. That's why each nation now in Europe talk about again to build nuclear power plants. I'm not so fan about this idea. I think we have enough sun power, we have enough wind on the earth that we can produce enough electrical power that we also can feed these super mega computer farms than we need for virtual reality and really a good artificial intelligence. And it could be now that because we try to care our globe, We generate so much heat that we do not have enough time. However, we will find out it. But however, this is also an end-to-end perspective, and this is hyper complex, and so we need also all the instruments we is able. So the result is the slow transformation of the society on one hand, on the other hand, the progression we have in technology is maybe also because so many organizations try the difficult level of the problems today, complex and hyper complex, and they try to solve the problem with yesterday methods. My experience, that do not work. Now the final sport. We need the courage also to make things simple. It's not necessary I have the end-to-end perspective at all. It's maybe also helpful just I look for the CO2 balance, one company and one sheet. Then I have a simple solution. Because I believe in that a good estimate is much better than a wrong calculation. Also here by the mobility discussion we have. When I look here from the gasoline station and the plug-in of an electro carrier until kilometers I drive on the road, then it's absolutely clear the electromobility is much more healthful, is much more healthy than the diesel car. In this perspective. But is that the real truth? When I look end to end and I will have the impact of social negative actions, kiddies, children, the work by to find the stuff to make batteries and all this, and I look end to end of all of that, I'm not sure what the result will be. Is really electromobility the solution of the solution? I don't know. But however it is, we know so little yet, but enough to act. We have no time to wait. So it's sometimes much better we do something wrong, find out it's wrong, and then we change. And by the change, we can come in a closer trueness that we can really fix the problems we do have. What not works is that. The wrong mindset. What shall not be does not exist. So many people say, it's not complex. It's not complex. But it is complex. The next step is they do not understand complexity. Once somebody tried to explain me, ladies and gentlemen, we have to reduce the complexity of a system. Sorry, that do not work because the complexity is not a variable in a system. The complexity is inherent in the system. When I look into a building with 5 levels, the complexity level is 5. And when I reduce it, it's not the same system, definitely. The next one is often the people believe more in things than they know it. That is not helpful. And also, in my experience of the last 30 years, often I see the right person, but in the wrong rule. And at last, it's Occam razor. That means if stupidity or intention bring the same negative result, in my experience, almost the stupidity, mostly, is the trigger for the disaster, and not the intention. Conclusion. Virtual reality and artificial intelligence are neither evil nor blessing. It's just a tool. Definitely. It's a hammer, it's a hammer, it's a hammer. The conclusion is using virtual reality and artificial intelligence is not optional, it's mandatory. And this is the mousetrap of the time. The final word from John Burdett. We must promote head, hand, heart, and spirit in the same level, in the same intensity of passion. And the only way to change our world, to make it useful, peaceful, and we can really reach the positive effect of artificial intelligence and virtual reality when we educate the people right. And it's do not start by the university. It should start by the kindergarten. You can read it also in books. Some of them is in English, some in German. And there is also say, when we will have the positive effect of the Industrial Revolution 4, we have to change our organization and the mindset. Thank you very much for your attention.
Thank you very much, Markus. Thank you very much also to Luca. Your presentation were very interesting. I I listened very well to your speech, and I hope that also the participants have appreciated this railway talk of this evening. I don't know if there are some questions in the chat. I see that there is nothing. I don't know if someone wants to raise the hand to put questions. I've seen that before, as there was the presentation of Luca. There was yes, there's again a raise an hand. So please, Andrea Haas, you can you have the raise your hand. You can talk and put your question to the speaker.
Yes, thank you very much. Very happy about this presentation. Thank you. And of course, I have a question to Markus. He knows me, and we talk a lot about that subject. I'm really a little bit afraid of next future and how we handle the railway system. We can see a little bit Germany, we can see other examples, and I think a lot has to do by simplify too much and not treating complexity as we should do. And this gives us as engineers a good feeling, because we can settle it better and we have a rational approach. However, we destroy the complexity, and then we destroy, of course, as well the system. And I think this railway system at the moment, it ends up with a lot of costs, and we lose really control over it. My question to Markus, of course, is, I mean, when we have we look at the situation and we look at an organization, how we can learn to do the right decision, to choose the right methods, to not destroy a system and then also destroy it at the end. And I think we can take example. I don't want to blame Germany, don't take me wrong, but I think we can see there was a lot of simplification who was done in the past, and at the moment we all suffer because of that. And I'm afraid in Switzerland we do the same. I mean, that's a question to Markus. I mean, what can we do? How we can learn it? Because it's important. Sorry for that.
Yes, I try to find an answer. It's very difficult, you see, because I cannot read in the coffee base. I cannot read in the leaves of the tea. But what I think is very important, it's never a singular solution. It's never a solo solution. We come together, and this I remember to Jeremy Rifkin. He described the empathic civilization, and I think this could be inspiration, that we haven't to wait. We have contracts. We should come shoulder and shoulder and works, engineers together with economic people with scientists, scientists together with scientists from biological, medical, and so on. And this maybe will then the chance that we really can hold the perspective of hyper-complex systems, and we are not losing the track, not losing ourselves in the fog of hyper-complexity. And that means, for me, it's the only way to come together. That's why I talk about that. Technology-wise, we do not have problems. We can do everything. But can we come together with no restrictions? That is the challenge. And when we don't do that, we lose the game. We lose the game. Just a small little answer for that. I was working over 5 years together with Sergio Maccone. And our science contract was, what makes a winning team? And at last, we worked with more than 400 business leaders, and we find out what makes a winning team. As more quick you come for social interaction, emotional interaction between the members of the group, as more succeeding is the team. That's a simple fact. Friendship.
I agree.
Thank you very much. Are there any other questions? I read that someone would like to have the presentation. Yes, of course, it's possible. The presentation will be shared with all the participants. And I remember that this webinar, this talk is recorded, so you will have the opportunity also to review it. I don't know if there are other questions. If no, I want to put the question for Luca Gioiello. Luca, you have talked about the different technologies that are coming, that are used. You have put some examples, but I would like to know if these are permanently used or if they are in the test phase.
Now, there are some of them which started as reviews, like scientific research, and then they have been applied. But I think that we have a problem because we don't have the culture about using these tools. And the problem is we have the instruments, we have the knowledge, but in a practical way, sometimes it's hard to let this stuff being reality. And I think that's all about culture, you know? So I think that we should do something like that to share the culture about technologies. So we don't have to be afraid about them. We don't have to think that technology is just a solution, but we have to find out the balance. When we will understand that, maybe we will apply the research and some research that has been done, and it will be applied to the real life operations.
Okay. Thank you very much. Yes, we have also showed a slide where it's possible to see that, for example, in railway market, we have done a fourth of the study that were done for the road. So we are, in comparison with other transport modes, I think that we are also in the studying of this technology, we have done not as the other have done. And then there's also the point that you have explained now. Okay, so thank you. I see that there are no other questions and the time is over. So if no one wants to use these seconds to put the last questions, I would close here the talk. I thank you very much, the two presenters, because it was very interesting. And I want to say that we will have another talk, maybe will be in February next year. And as we are at the end of the year, I want to wish you a Merry Christmas and, of course, a new happy year. Thank you very much to all of you, and we see us in the next year. Thank you and bye-bye.
Bye-bye.
Thank you, everyone.